The effect of tires on fuel consumption. It's a scientific law of physics that to travel, you need energy. Most cars and trucks use fossil fuels to provide this energy. We all know that fossil fuels emit carbon dioxide, and carbon dioxide contributes to the problem of global warming. Therefore, it is essential to do everything we can to limit the harmful emission of carbon dioxide. Europe is seeking to reduce carbon dioxide emissions by the end of 2020. To reduce fuel consumption and reduce carbon dioxide emission, it means lowering the impact of the forces that move the vehicle. There are 5 of these forces. Let's have a look at them in a little more detail. First of all, let's talk about inertia. Inertia is the act of changing the velocity of a given vehicle. Secondly, gravity. This is inescapable, as it is the link to the weight of the vehicle. Thirdly, aerodynamic force. This is becoming widely recognized, and vehicle designs are being adapted to start to overcome it. And fourth, let's not forget the effect of mechanical friction, the moving components of the engine and drive shaft. There is a 5th force, which is hidden and difficult to understand, but it is responsible for nearly 1/3 of the fuel consumption of the vehicle. Your tires actually consume fuel, so we must stop the thirst your tires have. Let's explain how. Under the weight of the load, a tire is distorted each time the wheel turns. This distortion causes flexing, compression, and shearing. It's essential for the grip and comfort, but as a result, it causes rolling resistance in return. The question is, why? Well, it's because tires are made from viscoelastic materials. This means once these materials have been distorted, they regain their shape only after a short period of time, and all the energy taken to distort the tire is not fully restored. This too is scientific law of physics. Some of the energy is transmitted and lost in the form of heat that warms up the tire. This loss is a good example of a major component of rolling resistance. If we take a closer look, rubber compounds are composed of long molecular chains and columns, and these are linked by chemical bridges, which give elasticity, strength, and rigidity. Rubber is often filled with carbon black and silica for resistance to wear, and heating occurs due to the friction between the molecular chains shown in this animation. If we adjust the composition of this complex chemical mixture, we can successfully reduce rolling resistance without sacrificing the other vital characteristics a tire needs. This means we produce tires that consume less fuel than those that we have made in the past. There are several other factors that influence the rolling resistance and hence fuel consumption of a tire. First, let's talk about air pressure. On the left, we are showing an underinflated tire, and on the right, we show a tire with the correct level of inflation. Under the weight of the load being carried, the underinflated tire on the left is far more distorted compared to the correctly inflated one on the right. As a result, the underinflated tire consumes more fuel. Now, let's talk about wheel alignment. The most critical alignment angle is the toe setting on the steering axle. Excessive positive or negative toe will cause scrubbing and shoulder wear to the tire and increased fuel consumption. Toe can be expressed as an angular measurement. Toe in is the term used when the leading edge of the 2 front tires is closer together, and toe out is the expression used when the trailing edge of the 2 front tires are closer together. Zero toe is the expression used when the wheels are parallel. For trucks, every 1 degree of misalignment will effectively drag the truck several meters sideways for every 1 kilometer traveled forward. The natural driver reaction is to keep the truck in a straight line by applying a small amount of steering input. This gives excessive flexing and scrub to the tire, consuming even more fuel. The important points that we've now learned in order to reduce your fuel consumption are as follows. Firstly, you need the correct tire that exhibits low rolling resistance. Secondly, you need to maintain the correct inflation pressure. Thirdly, to maintain the correct wheel alignment setting. Attention to maintaining these three elements, and also the avoidance of overload, with good driving habits will maximize your tire life and reduce your fuel consumption even more. As a tire tread wears down, its fuel efficiency increases. Brand new tires will have a relatively high level of rolling resistance. The wearing rate of the tread reduces as the tread groove depth reduces due to less tread movement. As the mass of rubber is less at this stage, the energy required to flex it is less too, improving fuel consumption. Finally, once the tire is worn out, thanks to the GT Radial strong casings that allow a high level of retreading, means rebuilding and renewing the tire for future usage similar to any new tire, reducing consumption of natural resources and saving you money. Just think, if the millions of trucks and semi-trailers and buses in Europe were equipped with low rolling resistance tires and correctly maintained, the annual savings of fuel could be at least millions of tons. GT Tire is ensuring the environmental responsibility of the world of transport whilst helping you reduce your fleet operating costs.